In our last lecture module, we looked at how we needed to change our effective decision procedure in order to come up with a generalized procedure that will test for validity and invalidity in both the Boolean and the Aristotelian interpretation. We noted that to do that, we have to be able to modify the subject class of our premise diagrams when an argument is invalid in Boolean logic. So let's take a look at how we would go about doing that. Here's our universal affirmative categorical statement as symbolized in Boolean logic. As Booleans, we say, look, I don't know if there are any members of that subject class, and I don't know if there are any members of that predicate class. But what I do know is if all the members of the subject class, if there are any, are members of the predicate class, then that subject class and only subject class area, that part of my subject class circle that is outside of the predicate class, that would have to be empty. So I shade it in to indicate that nothing can be there, and that would be what has to be true at minimum in order for that standard form categorical statement, universal affirmative statement, to be true in the Boolean interpretation. If this is a premise diagram in an argument where the argument has been found to be invalid in Boolean logic, I want to modify my subject class of this premise diagram so that it satisfies the Aristotelian assumption, so that the subject class has at least one member. When I look at this diagram then, I realize, well, there's only one place in the subject class where I could put that one member. And so I put it in the intersection area there, the only area that is still open in that subject class. And I circle the X to remind myself that I'm only entitled to that information on the Aristotelian assumption that the subject class has at least one member. Here is our Venn diagram for the universal negative standard form categorical statement. Again, under the Boolean interpretation, we say, I don't know if there's a member of the subject class. I don't know if there's a member of the predicate class. But what I do know is if no member of the subject class is a member of the predicate class, then that intersection area there, that area that is in both circles, that would have to be empty. There couldn't be anything in there. And so I shade it in to indicate that it would have to be empty. If this is the premise diagram of an argument that is shown to be invalid in Boolean logic, and I now want to test it for validity in Aristotelian logic, I again go to the subject class of that premise diagram, and I look and see, does it have a member? Since this diagram does not have an X in the subject class, I'm going to put one in. There's only one place I can put it, so I put it there in the S and only S area 1 part of my subject class, and I circle it to remind myself I'm only entitled to that information if the Aristotelian assumption holds true. What about my particular statements? Well, if this is the premise diagram of an argument that has been shown to be invalid in Boolean logic, then I go to my subject class of that premise diagram and I say, does that class satisfy the Aristotelian assumption? Does it have a member? And in this case, there already is a member. There's an X in S already. So I don't have to do anything to this diagram. It satisfies the Aristotelian assumption as is. If this particular negative diagram is the premise diagram in an argument that I've shown to be invalid in Boolean logic, and I want to now check it to see if it's valid in Aristotelian logic, I will look at the subject class of this premise diagram, and I will ask, does that subject class have a member? Does it have an X? Since it does, I don't have to do anything to this premise diagram either. And so we see that only the premise diagrams and only the subject class of the premise diagrams have to be modified for these direct inferences. And that means that only the universal statements, only the type A and type E statements are affected. What about if I've got a negation? Let's say that my argument was saying that the universal affirmative was true. This is how that diagram would look in Aristotelian logic. If I want to symbolize that it's false, that all S are P, then I would say, okay, in order for all S or P to be true, that area 1, that part of the subject class that isn't in the predicate class, that would have to be empty because all of the members of the subject class would have to be in the predicate class. So I would put an X in there to symbolize that there is at least one member of the subject class that is not in the predicate class, and hence it is false that all S are P. P. If that is my premise diagram for my premise, that it's false that all S are P in an argument that is invalid in Boolean logic, and I'm going to test it for Aristotelian logic, I look at that diagram and I say to myself, does it have a member in that subject class? Since it does, I don't have to change anything in that premise diagram. If I have a universal negative as a premise, then that's how that diagram would look in Aristotelian logic. A circled X in area 1, area 3 is shaded, the intersection. If I had as my premise, it's false that no S are P's, then I would have said, look, I don't know if there are any S's, I don't know if there are any P's, but if it's false that there's an S that is a P, then, but if no S or P is false, then there has to be at least one thing. It is an S and it is a P. So I would put that X in the intersection there, and that would be how I would symbolize it's false that no S or P. Now, if that is my premise diagram for an argument that is shown to be invalid in Boolean logic, I go to that premise diagram, I go to that subject class, and I ask myself, does that subject class satisfy the Aristotelian assumption? Does it have a member? And the answer is yes, it does. It's got an X inside the S circle in area 3, so I don't have to change this diagram either. What about those particular statements? Well, if I have a particular statement, some S or P is a premise, then I would symbolize it with an X in the intersection of S and P. There's at least one thing. It's an S and a P for both Boolean and Aristotelian logic. If I have a premise that says it's false that some S are P, then I say, if it's false that some S are P, then it's not the case that there's at least one member of the subject class that is also a member of the predicate class. That intersection, therefore, would have to be empty, and so I would shade it in, and that would be how I would symbolize it's false that some S or P in Boolean logic. That's how the world would have to be in order for the negation of that particular affirmative statement to be true. If that is the premise of an argument that is invalid in Boolean logic, and I want to test it for Aristotelian logic, I look at that premise diagram, I look at the subject class, and I ask, does it satisfy the Aristotelian assumption? Does it have at least one member? Since it doesn't, there is no X in it, I put one in the only available area. I circle it to remind myself I'm only entitled to that on the Aristotelian assumption. Finally, my particular negative. If I have a premise that says some S are not P, then I say there's at least one thing. It's in the S circle. It is not in the P circle, and so I put my X in area 1 there, and that would be how I would symbolize my premise in Boolean or Aristotelian logic. If, however, my premise says it's false that some S are not P, then I say, then it's not the case that there's at least one thing. It is an S, and it is not in P. So I would shade that area of S outside of P to indicate that there can't be anything in there because it's false that there's at least one thing that is an S and not a P. And that would be how I would symbolize that premise in Boolean logic. If this is the premise in an argument that is invalid in Boolean logic, then I look at that subject class and I ask, does that subject class have at least one member? Does it satisfy the Aristotelian assumption? Since there is no X in the subject class here of my premise diagram, I put an X in the only area that is open, and I circle it to remind myself I'm only entitled to that on the Aristotelian assumption. Now that we've figured out how to symbolize our premise diagrams, how to take into account that Aristotelian assumption, we can also see both why all of the new logical relationships have to hold, but also that the symbolization of it's false that some S or P, for instance, is going to be the symbolization for no S or P being true because they have that contradictory relationship. But I can also now look at these diagrams and see why all the other relationships are necessary. If all SRP is true in Aristotelian logic, then area 1 is still empty, but area 3 has to have an X because S has to have a member. If that is the case, then my universal negative statement has to be false. It requires that that intersection be empty, but now it cannot because the Aristotelian assumption is that there is an X somewhere in S. And we can do that for each of the relationships. I'll leave that to you.